Okay. Okay, so we are looking at 4.7. Okay. And if you remember, 4.7 was about inverses, and we don't have a ton of notes left to do. I just didn't want to rush through this chapter either. Inverses is where we went like backwards, or we undid what we had done before. And so the big problem here, these were the few problems that we've already done, and we're going to do more of these. That's on the worksheet I just passed back. That to the negative first power means that it's an inverse. And then I'm going to give you a ratio or a fraction, and your answer is going to be an angle. So in these types of problems, our answer is an angle. Whenever we see that sine or cosine or tangent to the negative first, your answer is an angle. I don't care if it's in radians or degrees unless I specify. So when we practice in a little bit, we'll write them in both. The one important thing that I mentioned last week that I won't go too in depth with, you can see the last video where I kind of explained why it made sense today. I'm just going to tell you, you need to know these things. When we do inverse sine, you're always looking in your unit circle at quadrant 1 and quadrant 4. Same thing for tangent. That's why they're both highlighted yellow. When we're looking for inverse sine and inverse tan, we're going to be in quad 1 and quad 4. When we're doing inverse of cosine, we're in quad 1 and quad 2. Cosine is positive in quadrant 4, so I can't look in 1 and 4 because then those are both positive numbers. So the negative quadrant I go for cosine is going to be Q2. Okay. So we're going to use that information a little bit. The next thing we did is we plugged things into the calculator and talked about how it would work. Remember, I think a couple of you guys asked me even while we were testing yesterday, and I can only answer so much, but whatever I tell you we're in, that's what mode you need to be in the calculator. So this one's talking about degrees. So we were in degrees in the calculator. Think about it that you and your calculator need to speak the same language. So if I'm talking degrees, the calculator needs to talk degrees back to me and vice versa. So you can switch between them, but think about what are you plugging in? Are you plugging in a degree or a radian? That's what you want the calculator to be in. Okay. I'm going to erase a little bit of this because we didn't do all of these yet. This problem. I think we did letter B together. Am I right? Okay. Letter B together. So now we're going to do A, C, and D. And I'll just kind of review quickly what we did in D so that we can do it for the rest of them. And then we're going to skip the word problems. I just don't want to do those. 4.8 is exclusively word problems. I'll get you some tough ones then. We don't going to worry with these. Okay. So when these say find the exact value, that means I don't want to use the calculator. And honestly, on these, I cannot use the unit circle because these are not ratios I'm used to seeing. I'm not used to seeing like 2/3. So that's how I know I'm going to draw myself a picture and go from there. I'm starting by looking at the fact that I have sine to the negative first or inverse sine of 2/3. That tells me that I don't know what my angle is, but it tells me of this angle, my opposite is 2 and my hypotenuse is 3. It also tells me sine is positive, so I drew my sine or my triangle in the first quadrant. And I labeled my sides. 2 was my opposite and 3 was my hypotenuse. From there, I didn't know this other side. I didn't know my A, my adjacent side. But we've done a ton of problems like this where I gave you 2 sides and you find the third. You're just going to do Pythagorean theorem. 2 squared plus x squared equals 3 squared. Solve, and I get x equals √5. Once I have all the sides of my triangles labeled, all I have to do then is figure out which trig function do I really want at the end of this. It wants secant. So secant of this triangle, secant of this angle is going to be h/a. So 3/√5, and then we rationalize. We're going to do 3 more of these. So if that still is a little weird for you, totally fine. I will tell you, and those of you who took the test probably could vouch for this, a lot of what we did on the test looked like this, right? If you did not know how to do this, you're going to be screwed on the test. But if you do know how to do this, there's a lot that will feel pretty easy because there's a lot of just triangles, drawing, labeling. I promise I'm not trying to play tricks on you. That is a lot on the test. You got to know that.
I have a question. So like on the test, does it matter like where we put the triangle? You just draw right here.
You need to draw a triangle because it will matter positives or negatives. So I will tell you enough information for you to know what quadrant it's in.
And you have to like put it in there.
And you need to put it in that quadrant. And you also need to make sure that the line goes down to the x-axis never draw me a triangle like this on the y-axis. Also, I always forget that people even think this. Don't draw a triangle like this, where the 90 degrees is at the origin. That's not it either. I want the line to hit, to be a right angle at the x-axis, and I want the theta to be in by the origin. Okay. Because that's another thing that if that might mess you up and get you. Okay, so let's do a couple more. Let's just go down to D since we're right here anyway. It says cosine of inverse sine of -1/5. Okay, I know sine is what over what in terms of opposite, adjacent, hypotenuse? O over H, good. If you remember from what we learned earlier, and I'm just going to scroll back in my notes just to prove a point. Inverse of cosine is either in quadrant 1 if it's positive or quadrant 4 if it's negative. So what quadrant and am I going to draw this in if I'm doing my inverse sine is -1/5? In quadrant 4, very good. I'm going to draw my little axes. Got my little triangle. I've got my opposite, I've got my hypotenuse, I just don't have my adjacent. And so just like I said, we did a lot in the last part of the chapter, we're gonna find that by doing Pythagorean theorem. So I'm gonna do a squared plus b squared equals c squared. The only thing is to remember that your c is your hypotenuse, so that's 5. So I need to make sure that my graph looks something like this. So I'm gonna do -1 squared plus x squared equals 5 squared. 1 plus x squared equals 25. 4 square root 24 is 2√6, I believe. If I can rationalize it or simplify that radical, I am going to do that. Is that 2√6? Is that going to be positive or negative when I put it on this picture? Positive, because I went to the right. So I'm going towards the positive exit. This is all positive over here. My negative in this case comes from when I went down. That down is that negative. So think about when you put your number on your graph, does it stay positive like we found it to be? Or when I put it on there, will it be a negative number? Last step is it says cosine of this angle. I don't care what my angle is. I don't care what that is. I just now want to know what cosine of that angle is. And so we can do adjacent over hypotenuse, 2√6 over 5. √6 over 5. All right, we're gonna jump and do A and C. Also kind of run through these with you, and then the last thing we're gonna do is check these in the calculator, practice plugging them in. So I'm gonna look at letter A. Does anybody have any questions yet? You might feel good to kind of start without me. My only concern here is I don't actually have a fraction on this one. What would this fraction be? What's 0.1 written as a fraction? 1/10, very good. So if you, once you have that, you probably can do some of this on your own. So I'll talk you through it, but if you're like, think that you got it, you go on your own. We know tan is opposite over adjacent. So I'm gonna go draw my triangle. I do know that I'm a positive 1/10. So that means I'm gonna be in Q1. I'm in quadrant 1 because tangent's only in 1 or 4, and we know that we're in 1 because it's positive. I labeled my opposite, I labeled my adjacent. Now I just have to do Pythagorean theorem to figure out what my hypotenuse is. And square root of 101, I feel like should simplify down more, but I think that's prime. I think that's as good as it gets. Okay. And then now what trig function do I want now that I have all this information? Fine. And for sine, you can just do opposite over hypotenuse, rationalize if needed, and then we're done. We will have to rationalize. So that root 101, I can multiply on top and bottom, and that becomes root 101 over 101. Are we doing okay, or am I moving too fast? Okay. Okay, the last one I also think you can kind of do on your own, but it's a little bit funny. This time I gave you cosecant. Cosecant is the reciprocal function of which one? Which one? Sine, very good. Cosecant is the same thing as 1 over sine. However, if I flip cosecant, or if I flip 1 over sine to just be sine, I can flip the fraction and think of that as my sine. I can think of this as 2 over 3. Just like we know sine is opposite over hypotenuse and cosecant is its reciprocal, hypotenuse over opposite. I'm thinking about sine. My sine is 2 over 3. So now I can do what I was just doing. Draw my triangle, label my sides, Pythagorean theorem, and on and on and on. Remind me though, before I start, what quadrant am I going to be in? 1, very good. If it's positive, we're in 1. Opposite hypotenuse, I don't have adjacent, so I'm gonna go find that, and then I'll figure out what my tan is. Okay, and then I want to do tangents. I know tan is O over A. Remember this root 5 is going to be a positive number because I'm going to the right on the x side. Everything in the quadrant 1 is positive. So tangent of this angle is going to be 2 over root 5, which is the same thing as 2 root 5 over 5. Before we do a little bit more practice on this, I do want to go check our answers with our calculator. So go ahead and get your calculators out so I can kind of talk about how do we even put this into our calculator, and then we're confirming that it's going to be the same answer. You don't really need to do any work over here, so you can like write down the decimals we get, but for the most part, what's more important is that like you're typing in your calculator or watching me type it in and seeing like, could I do that? Making sure that you understand how the buttons go. We'll just start with the first one. It says sine of tan to the negative 1.1 and parentheses. This one's pretty basic because we're just doing our normal trig functions. Now, I'll do both ways, but it does not matter if you're in degrees or radians. Technically, do I know what my angle measure is in any of these problems? Have I known what any of my angles have been? No. So I've never had to know. I don't have any idea. I don't need to know. All I care about are these ratios. So you can be in degrees or radians because you're not talking to your calculator in terms of either. So it will give you the ratios no matter what the answer is in degrees or radians. So your mode does not matter right now. Okay, so I'm gonna do sine and then second tan to get tan to the -1 and then 0.1. Close all my parentheses and I press enter. Oh, I put 1, not 0.1. Wait a second. Try again. 0.1. There we go. There we go. So I got 0.0995. Now, the answer we got was a fraction with a radical. I can check to see if it's the same thing as this by going to my calculator and saying, hey, does square root of 101 divided by 101 equal this weird decimal that I got a minute ago? I'm gonna go check. Square root 101 divided by 101. Oh, nice. Gives me the same thing. Okay, cool. Let's jump over and do letter B. Ooh, secant. How do I write secant in the calculator?
1 over.
1 over cosine. So I'm gonna think about writing this as 1 over cosine, and then inside the parentheses is that sine to the -1, 2 over 3. So 1 divided by cosine. And then second sine, 2 divided by 3. Got 1.34. I'm gonna check my work by doing 3 root 5 divided by 5 in my calculator now. So 3 square root 5 divided by 5. Oh shoot, it's the same number still. How exciting. All right, one more weird one and then letter D will be super easy, but we'll end with that one. This last weird one, it says tan of cosecant to the -1st, 3 divided by 2. We cannot treat this like we just did. So we know cosecant's the same thing as 1 over sine. We can't type in tan and then parentheses and then 1 divided by sine to the -1st of 3 over 2. It doesn't work like that. You only can do 1 over that function when you're doing the normal trig function when you don't have the -1. When we do have the -1, do you see how on the work that we did, I made us go from cosecant to inverse sine of 2 over 3? How I flipped the cosecant to just be normal sine, and so I flipped my 3 over 2 to be 2 over 3. That's what we're gonna plug in the calculator. So we're gonna do tan of sine to the -1st of 2 over 3. Which I gotta check and see if that's the same thing as 2 root 5 over 5. Let me check. 2 square root 5 divided by 5. Okay, nice. That's the same answer. We're doing good so far. And then the very last one, I think you can just plug that all in on your own. So try that one. Cosine parentheses, second sine parentheses, -1 over 5 parentheses, parentheses. And see if that is the same thing as 2 root 6 over 5. Cosine second sine -1 divided by 5. Okay, perfect. I got 0.9798. Okay. And we are doing good. That's all the notes for 4.7. Okay. Give me 1 second. I'm gonna get directions when it can go. Okay. Everybody good so far? Okay, before we start, I handed out this worksheet. I told you that this isn't for a grade. I just want to practice. I want you to flip over to the side that looks like this with the 2 columns, not the 3 columns. And I want to just do the whole first column as much as you can. So I'm going to be quiet for like, I don't know, 5 to 10 minutes. and then I'll call you back together, and then we'll do as much of that first column all together as we can. My biggest, word of advice is if you are not sure, just skip and go to the next one, because like the first one's tan, which is a little bit harder. The sine and the cosine ones are a little bit easier. Feel free to use your unit circle. I would not use your calculator on this one. Use your unit circle. It will give you the most exact numbers. And I don't care if you give me answers in radians or degrees. Anybody else questions? Okay. I'll just pause this for now. Resume. Okay, perfect. Okay, so now that you've had a little bit of time to try these, hopefully either you got a few answered or you're like, oh, I actually have no idea what's going on. Let's figure this out. Okay, so remember, these are all I'm giving you the ratio and I need you to give me the angle. So these are the ratios that we're essentially like looking for on our unit circles. Remind me before we start though, sine, inverse of sine, inverse of cos, inverse of tan. What quadrants can I find those? Or am I looking for inverse sine? Quad 1 and 4, good. What about cosine? 1 and 2. And what about tangent? 1 and 4. It's the same as sine. So I'll do kind of like green means positive, that means grow. So these are all positive ones. So when we're positive, we're looking at Q1. So it's all Q1 when we're looking at positive values, positive ratios. When we're looking at negative ratios, and make that red for negative, we're looking in Q4 for sine, we're looking in Q2 for cosine, and we're looking in Q4 for tangent. So those are kind of a nice little reminder of where are we looking for these. Because if I just look for like √3/2, I could find several. So I want to make sure I know where I'm looking. Okay. Tan's a bit of a tricky one to start with, but let's just start it off strong. This one, tangent. We know tangent is in terms of y and x. What is tangent? Y over x, good. So I want to find something where y divided by x is going to give me -√3. If I know that this tangent, if my inverse tangent is negative, what quadrant am I in? 4. I'm looking in quadrant 4. So I'm going to kind of ignore the rest of my graph. I'm going to only care about quadrant 4. Now, the more of these we do, the more you'll kind of know which two angles to narrow it down to. I already know it's not going to be one of the quadrant angles. It's not 270. It's not 0. It's not 360. Because anything, those will not divide to give me radical 3, right? Would the 45-degree angle, would that 315, would that divide to get me √3? No, but I don't know which one, but either the 60 or the 30-degree could give me √3 because they both have √3 in their answers in some capacity, right? That being said, which one do you think it is? Which one do I need it to be in order for y divided by x to give me √3, -√3? So we're gonna do y divided by x. If I did like 1/2 divided by √3/2, would that leave me with just √3? No, Charlie's shaking his head. What about if I did √3/2 divided by 1/2? Do you think that would work? So let's do that one. Let's solve it out. Now, once you've done enough of these, you don't always have to solve them out. But this one we're not sure still, so let's do it. -√3/2 divided by 1/2. When you divide a fraction by a fraction, we're going to multiply by its reciprocal. So I'm going to multiply by 2/1. Those 2's get to cancel out, and that √3 is just left by itself on top. There's no denominator, and so that's how I got there. This work isn't really needed. This is just me checking. So essentially, I want to know what angle has the point 1/2 comma -√3/2. Which angle was that? That was my 5π/3 or my 300, right? So you can call it 300 degrees, or you can call it 5π/3. Some people like to think of it as like going from the 360 and going backwards. So technically that's -π/3. That's a coterminal angle there, but we can think of that as working as well. I got to start on a real tough one, but the next few I think are a little bit easier. You guys ready to look at the next couple? Okay. The next one says inverse sine of √3/2. Sine is which variable, x or y? Y. And if it's a positive √3/2, which quadrant am I looking in? 1. Very good. We're looking at quadrant 1. And so I'm just looking for a y in quadrant 1, and I want to know what its angle is. That's √3/2. It's going to be right here, right? Pi/3 or 60. I don't mind which way you call it, 60 degrees or pi/3. I'll list both. You do not have to list both, but they'll get to be a point that you'll choose and you'll want like one over the other. Again, your only answer is your angle. You don't have to write this other stuff. I just find it helpful. All right, cosine. Cosine is which variable? X. If it's a positive cosine, which quadrant am I in? 1, very good. And what angle in quadrant 1 has an x or a cosine of 1/2? I didn't even move my screen. I'm in the right place, right? 60 or pi/3. Okay. All right, I've got cosine of 0 next. Cosine is my x. And technically, I would call 0 like not positive and not negative. So it's somewhere in quadrant 1 or 2. I'm looking for somewhere in quadrant 1 or 2 where my x is 0. Which angle is that at? It's not at 0. That would be my y would be 0. 90. X, cosine's my x, so I want my 90 or my pi/2. You guys are doing awesome. All right, tangent. A minute ago, you told me tangent was what with x's and y's? Y/x. So I'm looking for an angle that when I do y divided by x, I get 0. I would again say this is neither positive nor negative. Hint, when it's neither positive or negative, it's probably in between those two quadrants. So that last one, the angle right between quadrant 1 and 2 is 90 degrees. The quadrant in, or the angle in between quadrants 1 and 4 here, my y is 0. So if I do 0 divided by my x, which is 1, 0 divided by x is 0. That's what I want, right? This is on some people's quiz on the last time. You would write, you'd write this. You'd write your 0/1. I know that's a terrible highlight. Sorry. You'd write your 0/1, but then you'd call that undefined. Is that correct? What would be undefined? 1/0. Good. The flip of it. So there were a couple of you, I think I maybe even gave some carried through points after a while because you had the right like ratio, but then you read it as the wrong thing. So just make sure that you're reading it correctly. And so that means at 0 degrees or even 0 radians, or you could even call it 360 degrees if that makes you happy, or 2 pi. That is my inverse of tan. All right, nice. The last two that we're going to do together are cosine and sine. We're just going to search and find. So cosine, inverse cosine of √2/2. What angle has a cosine of √2/2? 45. Very good. See, on that one, I didn't show any work because that's kind of what has been in my head the whole time. But if you need to see the work, cosine is in quadrants 2 and 1, so it's going to be in 1 this time, and cosine is x. So I'm looking somewhere in quadrant 1 for my x, that's √2/2. And then last, I've got sine. Inverse sine is -1. If it's negative, we know sine would be in quadrant what? 4. Very good. And we know sine is y, so we're looking for a y in quadrant 4 that is -1. 270 or 3 pi/2. And you could even do the coterminal angle and call it negative pi over 2 if that makes you happy. I want to just do 2 more on the next section just to kind of contrast what we were just doing. How does 15 look different than 13? There's no parentheses. Is that what you said? Yep, no parentheses, that's true. What else is different? It's what? Starting with the angle. So Sterling just got right to the point. I'm going the right way now. I gave you the angle and you want to give me the ratio or the number that comes from it. Above it, I gave you the number and you gave me the angle. Now we're going the opposite, or really the right direction that we're used to going. So sine of 270, I'm going to go find 270 and I know sine is y. What's my y at 270? -1. Perfect. Let's just do one more. Let's just do the secant one because secants are a little bit funny and then we'll call it a day. It's a secant of 210. Secant is the same thing as which trig function? 1 over cos, very good. And I can think of that, since I know cos is x, I can also think of this as 1 over x. So I want to go find x at 210, and I want to do 1 over it. So 1 over my x at 210. Okay, well, here's 210 and there's my x. So I'm going to do 1 divided by -√3 over 2. For the most part, this is on our most recent quiz too. A lot of us did really well with this, but in case you were like, no, I got to this Miss White and I did not do this right, let me just work it out for you. I can think of that as 1 times -2 over √3 multiplied by the reciprocal. So I get -2 over √3. And then I just want to rationalize √3 on top and bottom. So -2 √3 all over 3. Okay. All right, again, this worksheet I don't ever really need to see again. I don't want to collect it, but I want to give you problems because there will be a part on the next upcoming test that looks like this. So I wanted to make sure that you had some examples. And I just emailed myself these keys so I can post them on Schoology. So if you're doing it on your own and you want to see the answers. No, you need to know your unit circle by that next test. So the next few days, we're gonna practice doing some stuff with the unit circle to help you get that kind of memorized up. All right, I'm gonna call it quits on this.